All right, on the bench, we got another General Electric here, 3-5875A, aka the Superbase. And this is my fourth one this year that I've seen with various problems. But this one actually belongs to Boat Anchor CB Repair. And he's got a channel on YouTube as well, and you can actually see him receiving this. He bought this on eBay at a really great price, which I couldn't believe, but I'm glad he got it at that price. So yeah, this is his, but it has an issue. First issue is we got no power going to the rest of the radio. When I had it on earlier, this was just, the mode lights were just coming on dim, and the channel display was really dim. But right now, it's been on for, I don't know, half hour or so. Now it's completely dead, except for the clock. So first order is to get this diagnosed, and take it from there. See if the rest of the radio is working. See if it's actually transmitting and receiving. So yeah, let me get at the switch first, and we'll take it from there. But physically, this thing is in really great shape. Your typical dust inside of this clear panel here. That they all do that. You can take this whole radio apart, clean behind that, and you go to put this back together, and then the minute you turn on the radio, the minute it gets hot, all that static electricity, this thing gets charged with static electricity, and it attracts all the dust again. So it's kind of I don't know, kind of like the downfall of the setup, because this isn't completely sealed, but it is what it is. Everybody loves these radios. I like them, when they're working right. They're great performing radios, but when they are broken, man, they are a bear to work on. For me, it's still, this is probably top 5 radios for me, but probably not number 1. I have a couple of other radios I prefer over this that actually does perform better. It's not my opinion, it's fact. If you look at the Telsat SSB 140, it'll definitely give you a little bit better performance than this radio. But I think this thing is kind of like a legend. So between this and the Cobra 2000 GTL, they're probably the most two, I guess, wanted radios. But at least the Cobra 2000 GTL, you can, you can still find them at a ridiculous price. They're still around, but you don't see many Superbases around, and when you do, they are super expensive. And I wouldn't pay the amount of money that these things are going for. But anyway, let me get this non-power issue or no power issue fixed first, and then we'll see what's going on with the rest of the radio. Alright, stand by. Alright, well, you guys can see how much of a pain in the butt this thing is to work on. So, this thing actually had 2 issues. One was the switch itself, which was dirty. I'll show you that. Second was back here at the AC plug. See those 2 terminals up on the top? So that's your right in there. That's your DC disconnect. So you got to make sure you use the right style plug. I'll put you guys up on a tripod in a little bit here, and I can demonstrate exactly how this works. So this plug actually pushes up on that tab that's right there, and that's your DC disconnect. So if you don't use the right style plug, normally you will use like a square plug, not the one with this notch in it. Although you can use this one. But you got to make sure that you use it. You should have the right plug, but anyway, you want to make sure that the plug actually pushes up on that disconnect. And the only reason why is because that's kind of a protection for, in case you have, I don't know why you would ever want to have, or why you would have both the DC and the AC plugged in. But if you don't have that disconnect in there, it can give you some pretty nasty issues here. You know, backfeeding through to the power supply. You know, getting AC voltage. So that's pretty important to make sure you never have both these, the DC and the AC, plugged in together at the same time. It's common practice. Some base units will have a switch, and you know, you do it that way. This is the switch. The actual plug is the switch. So super important to have the right plug for this radio, or any radio that uses this style DC disconnect. Alright, so, and then the switch. Do not attempt to take these apart. You're going to regret it. They're super complicated, small pieces, and you might break some tabs. So when you run into a case where you have a faulty switch, this is the best thing to do, is to take your drill. Alright, slow. You can't go slow enough. Make a hole on the bottom. Now you're going to find that this thing is, this switch, you have contacts on one side, contacts on the other, meaning that this is split down the middle. There's a plastic piece split down the middle. So you want to drill kind of like at an angle to get out to that side, and then drill at another angle to get out to this side. And then you're going to spray in your deoxit right in there, because you have no access to this switch, this particular one. There's no holes, no nothing. It's completely sealed. Don't ask me how it gets dirty, but they do. And you want to spray in there, and then you want to work the switch back and forth, back and forth, back and forth, until you finally get a working switch. Alright. Back here, I'm just going to warn you guys, there's AC voltage here. There's AC voltage here on this side of the transformer. So take caution. If you want to get bit by 120 volts AC, that's, you know, just make sure that you take the right steps to protect yourself. Probably won't die, but give you a nasty bite. So yeah, there is AC present here when it's plugged in. But anyway, I have DC plugged in there right now. So let me get you set up on a tripod, and because I'm going to need two hands for this, and you can see exactly how this works. Alright, stand by. Alright, so I tried to get the whole radio in view here. So I'm going to be working the switch here. So right now this is plugged in DC, the DC plug, which is going to the power supply. So you can see it's on. Alright. So now what happens is when you put the plug in, I'm up here in the top left corner. When you put the plug in, it's going to push these two contacts together, as I'm doing here with the paired tweezers, and that's going to disconnect the DC plug. Alright, so this is why it's super important to have the plug facing the right way, or what this should have is just a square plug on both sides. But anyway, I'm going to plug it in with the notch facing the top, and you're going to see that it's not gonna, no, I have this unplugged, so don't, I'm trying to demonstrate here, so don't have both of these plugged in if you're trying this at home. So anyway, when I plug it in with the notch on the top, you can see it doesn't disconnect the DC. So now I'm going to flip the plug over to where it doesn't have the notch, and you can see it shuts off the DC. So that's why it's super important to have this plug facing the right way. Or I guess you don't have to worry about it if you're just going to use this on AC, and if you don't have a, you know, a DC power supply, I guess you'd never have to worry about this. But, you know, some of these ham shacks, you know, everybody has their own, you know, power supply, DC power supplies, and, you know, whatnot. So this is just a precaution. So yeah, either use the right plug, or make sure that the DC and the AC are not plugged in together. All right, so yeah, that's the switch. Like I said before, sometimes you'll have base units that will have, you know, a switch, an actual toggle switch in the back, you know, to switch between AC and DC. But yeah, I hope this is just a precautionary thing for some people, because I've never had it happen to me, but I would assume that you would backfeed AC, you know, into your DC power supply, and you know, that would be for a bad time. But yeah, these things are just a bear to work on. You got to take everything apart. But now that I do have everything apart, I'm going to take advantage of it and just go through all these switches and potentiometers, whatever I can get to. I'll just spray some deoxit in it, and once I do that, I'll get the faceplate back on, get everything back together, and then we'll do a preliminary test to see if it does receive, or if it is receiving, how well, and same thing on the transmit. Alright, stand by. Alright, well, got the radio back together, cleaned out all the potentiometers, switches, everything that I had access to. It's been cleaned. So, hook it up, no transmit, no receive, both, 0 on both. Then we all know about the dreaded VCO issue that these cybernets have. This one, as well as the bigger one, with those Varacta diodes going bad. So one of the first things I do is, when I have one of these radios that has you know, both no TX and RX, I immediately go to the synthesizer alignment, and I go right to here, DC meter to test point 1, channel 1 AM upper sideband, either one, and then you adjust the VCO for 3.6 volts. So got the DC meter in the test point 1. It's grounded off of a can here. And yeah, as you can see, we got nothing here. Nothing at all. And no matter how much adjustment I do here, and you got to be careful with these. You have to have the right tool for this, and you have to go very gentle, because if you break that core, you're screwed. But as I'm turning this, nothing is happening. So I'm turning the VCO here. Yeah, so we got a bad VCO. So everything gets halted right here, right now, until I can figure out whether to try to fix this one, or source one. There's a couple of places that make replacement VCOs for this. Alright guys, so I have the VCO out, and you can see it's already in pieces. But yeah, this is the, let me try to show you guys the radio here. You can see these can be a real, like I said before, real pain in the butt to work on. But anyway, here's the VCO. And so you want to be really careful when you are doing this. In fact, it's probably easier to just buy a replacement VCO. But I've already done a few of these, and I have an NTE 612 Varactor. I actually have 3 more of these left. So rather than purchasing a new replacement VSO, I'm just going to go ahead and repair this one. So you got to be really careful if you are doing this. So this kind of goes like this. This is the first layer, and then this would be a second layer that goes over that, and then the third layer. So this is how it's layered. And what you want to do is you want to take a nice sturdy razor blade, preferably something like this, a Stanley, and a nice, razor blade. I don't suggest using like the snap blades. They can be a little like floppy, and of course you always have to, use caution with yourself. But what you want to do is you're gonna have this. First you're gonna pry this can off here. That's relatively easy to do. You can just kind of get in there with a really fine bladed screwdriver, flat. And then you're gonna come across this green cover. Now this is where you want to use this razor blade, and you're gonna slice down all 4 corners. Alright, and then you're gonna kind of gently pry this up, because the core, well, first what you want to do is actually take the core out. You definitely don't want to mess that core up. And then go ahead and proceed like I just showed you. So the core actually screws into this green part here, and not into that actual into the actual VCO. Alright, so, and then you're going to come across the metal part, and you're going to do the same thing, but you want to kind of do it at an angle like this, and believe me, this will cut through it. Use a nice blade, use a nice new blade. This is nice heavy duty. This isn't going to really flop, and obviously be careful, keep your hands away, and believe me, it will cut. So now next, the actual Varactor. It is right beside that resistor, and there's the Varactor right in there. This one's a hell of a lot easier to do than the other Cybernet VCOs, because this one doesn't have the electrolytic, and this one's right there. So it's a little easier to do than the other one. So now, there's a few ways you can go about this. You can try drilling little holes and then cracking the epoxy. You can use like a Dremel type tool with a burr. There's many ways to do it. But what you're trying to achieve is access to that Varactor, but not nicking any other component in there. So go slowly, however you decide to do it. Just do things slowly. In fact, this leg that's right here, that is a part of the Varactor. That's actually one of the legs on the Varactor diode. So, yeah. And then we'll go ahead and put this NTE 612 in. It's not going to look like your varactor diode that's in there, but this is a varactor diode. Alright, I'm going to be putting that in. Alright, and that's it. So let me get at this varactor and then get everything back together, and then we'll see if we can get the voltage back to this VCO. Alright, stand by. Alright, so this is what you want it to look like when it's done. So you want to make sure that this is how it's going to look, so that NTE 612 is sticking out. You want to make sure that you grind out enough of the epoxy potting that the varactor fits in there, so that way when you go put your other pieces on, it's not going to interfere. But that's how you want it to look. You're going to cut, I still haven't soldered this in, but this leg is obviously going to be cut, and then that leg is going to stay. Alright, so let me get this soldered up, and you guys can kind of see exactly. Well, here, this is what you want to do. You want to kind of grind away enough so the varactor fits in there, but try not to nick that resistor that's in there and that ceramic capacitor that's in there. You definitely don't want to do that. If you do that, you're gonna have a bad day. But yeah, and then that goes in there. If you want to, you can repot this. I'm not going to, you know, just in case it ever needs to be replaced again. You know, it'll be easier. Besides, it's going to be shielded with, you know, all these pieces here, and it's not going to make a difference whether you pot it or not. Yeah, so let me get this soldered up. I'll get all these pieces back together. I'll put it back into the radio and see if we have voltage going to this VCO. Alright, stand by. Alright, well, I got the VCO back in. It's turned on. Let's put this to 1. I went through some of these pass-throughs as well, some of the more obvious ones that I could see that were bad. I just kind of you know what I mean, just kind of touch them. The way to do them is the best way to do these pass-throughs is with one of these, because I find if you use a desoldering gun, sometimes it's going to suck up the pin that's in there, and it's going to go right into the gun, and you don't want that. So one of these suckers like this is your best friend when it comes to redoing these pass-throughs, because if you heat it up just enough and you know you use one of these, it's enough to suck up all the solder on this side, but yet the pin's still gonna stay in place. And I've done a number of these already, and this is definitely the way to go, is with one of these. It's almost a necessity to do it this way. So anyway, with that being said, let's see if we have voltage back at test point 1. Test point 1. It's right here. Look at that, 3.6. So I actually don't even want to touch that. Should have 3.6. Yeah, I'm not even gonna. 3.4, 3.6. Man, that's good right there. 3.611. So you can see we got voltage back at the VCO. Let's see now if we actually have Let's see if we have our 10.240, because I didn't get that before either. So let's see here. Let me get this plugged into the frequency counter, and we want test point 2. Test point 2. All right, we can get rid of this. Test point 2 is, it's 4. Test point 1. Man, where is it? Right there it is, right in front of me. I just had it too. Okay, let me ground this. All right, that's good. Yeah, now we have, let me try to get you guys over there. See the frequency counter? All right, now we got our 10.240 back. So that's good. That's good. I'm pretty confident we have RX and TX back. All right, so now with that, man, this bench is a mess. It is what it is. Okay. So let's get our there it is. This is antenna A. Right here. Okay. Plugged in. Let's go to 19. And AM. All right, look at that. So, actually, let me take you guys. No, I'll leave you on the tripod. Take a look at that watt meter now. And see we have a carrier. We have a 4-watt carrier and we have modulation. Audio, 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 audio. It's not swinging much, but that could just be because of the caps and the alignment. But at least we have transmit back. Let's go to lower sideband. Audio, audio. Upper sideband. Audio, audio. All right, well, it is modulating, not well, but we do have TX back. So now let's see if we have RX. Yeah, I could put you guys back on this side. Okay. Oh, I can already hear it. That's good. Wow. Okay. I'm happy with that. Alright, so that's an S9. It's an S9 going to it. Yeah, it's a little off, but... Alright. Let's see. We got no lower sideband. That could be because of the alignment. But yeah, let me try. Okay, brought that back down to lower sideband. We are getting lower sideband. All right, so this is probably just an alignment issue. All right, well, kind of happy with the way this turned out, because sometimes, you know, these super bases can get the best of you. But yeah, so what I'm going to end up doing is I'm going to go back, because like I said, I only briefly touched a couple of the obvious bad pass-throughs. So what I'm going to end up doing is, let me unplug this for now. Where are you? There you are. So what I'm going to end up doing is going through all these pass-throughs that are in here and doing just like I told you with the little sucker, and going through it, because this is one of the flashlight here. When you look at the super bases, and that Midland's the same way. If you just touch these and you try to just reflow them with some new solder without sucking out the old solder, you're gonna notice it almost looks like when you melt aluminum, almost like this contamination in the solder, and that's what you don't want. So even though if you just touch these up with some new solder, the radio might end up working, but what you're worried about is longevity. You know, it might be a month, might be a year, but these little pass-throughs are gonna break again. So the best bet is to do like I said to do, and get as many as you can. And also, before you even do any of this stuff, check to make sure that the voltage is correct on the VCO, if you're doing this at home. So it's going to save you a lot of headaches if you just check that out first. Yeah, so you should have a little bit of voltage here. It's going to vary from radio to radio. But when you put your meter to test point 1 there, and if you change the channels and you notice that there's no difference in voltage, chances are that Varactor diode is bad in that VCO. And this would be the one you'd want to use, is NTE 612, just like the process I showed you before. I'm not going to go back through that. But this particular radio isn't in bad shape. Normally this capacitor just pukes out everywhere and starts to eat away at the traces. But fortunately, this one doesn't have that issue. Actually, the last two I've done haven't had that issue. So that's a plus. So what I'm going to end up doing is I'll probably do a part 2 now that I know that this radio is receiving and transmitting. I'll go ahead and recap this, and believe me, that is the worst part of this radio, is recapping this damn thing. And the alignment is the easy part for these radios. But yeah, that's kind of like a must with these radios, is doing these pass-throughs. It's going to save you a lot of headache. Even if you have a working one, let's just say you have a Superbase at home and it's working, and this has never been done to it, or if it's never been recapped, now's the time to do it while it's still working. You know, do your caps, and in fact, it might be easier to get at some of these pass-throughs while you're recapping, because some of them are hard to get at. You know, not impossible, but some of them are hard. Like this one here definitely looks questionable. But yeah, that's one of the things to do with it. And good thing with this particular with these particular pass-throughs, they go bad on this side. Not to say that they don't go bad on the other side, but generally they pop on this side. So that's a plus. I mean, what else can I say about this other than that? Yeah, these pass-throughs, the caps, the electrolytic caps, those are a must to do on these radios. And you know, at the end of the day, these are really, really nice radios. For me, they're second to the Telsat SSB 140. You know, I prefer those radios all around to work on, performance and everything. The only thing it doesn't have is this speech compressor, which for me is kind of, I don't know if it's a make or break thing for me, you know, with these radios. You know, I think a good mic helps. And the antenna switch is probably, you know, what makes this radio a little bit more desirable. But for me, those are two things that don't really matter. So for me, this is a second. This radio comes second as far as performance and desirability, I guess you could say. I prefer the SSB 140 hands down. This is a distant second for me, anyway. I'm sure a lot of you will have different different ideas or different you know, rankings, but for me, number one is the Telsat SSB 140, and this 3-5875A is second. But anyway, yeah, I hope you guys enjoyed the video. I will be making a part 2 with this thing all recapped. Believe me, you don't want to watch me recap this. It is annoying. There's a lot of swearing, a lot of frustration. Yeah, so you definitely don't want to see me recapping this live. But anyway, that's it for this video. So we had a non-working radio right from Jump Street, so no power. You know, we got that fixed. No TX, no RX, you know, no VCO voltage. So we got that fixed, and now we have a radio that basically now just needs, you know, recap and alignment. You know, we're back to kind of square one with this. So that's it, guys, for now. Stay tuned for part 2. All right, thanks for watching.